So we will move to the familiarizing or with fusion electronics design interface and modeling. So after this, we'll be going through the actual 2D pushing. So this is our interface. This is the normal interface that you see once you log into your account. So what you now have to do is, I believe that we all know how to, we have been taking through that, how to create a project and file. So I'll be going to mine where I'll be working with today, and you can create a new folder, but I already created one. So just to click here and then give it a name. So that's it. So here now under this file, I can now create a new electronics design. All right. So this is the first. This is the second. Now the first talks about creating. It's all about if you want to create a schematic design from scratch, this is the place. This is the toggle. All right. Then if you want to make reference with respect to existing files created, for example, let me just show us in a moment. You can use this, go through this and click on them, and then they will show, right? So, but we are creating a new file. So when you open up, the first thing that you will be doing is to actually turn on your libraries, because if your libraries are not on, you won't gain access to the components that you'll be using. You won't be able to use them. So you have to turn all of them. You can see that mine is mostly turned on. You can do it at once here, but sometimes it's kind of glitchy. So you just have to, if it doesn't work this way, you have to do it one by one. So here is where you get more info about your IDE. This is about your grid. This is when you want to highlight on something, on a component. This is about the layers of your PCB, but you're not using this yet. So the most important ones that we'll be using here is actually this guy, which would be for connecting. Okay, now this one is for naming a line. If you want to name a line, okay, let's just say that this line is positive or this line is negative, you use this. If you want to name if you want to name a component, sorry, you use this. So having turned on your library, if you want to give a name to your component, are we here? Are we there? Okay. If you want to give a name to your component, all right, this is the place where you click on it. Once you click on this, you click on the components, the name will show, then you give it another name. All right. Then if you want to name a line, let's just say you drew a line using this, and then you want to give it a name, then this is it. Now, this is for porting. You use this to add ports to modules you get, and you can also use it to, it's mainly used when you are creating new models. And here is for simulation, but it's kind of glitchy due to its version. So we won't be treating much of this. And here, these are the rest. But what we'll be needing here to actually create a PCB and get it to manufacturer level is this. Before you start modeling, as you model, you'll be running your prototype there on board, maybe breadboard, all right? Or better, but more painful, the Vero board. Then this will be when you are done creating your schematics. That's when you'll be using this mostly. So here is for moving, rotation, and then value for components actually. So let's just say we want to design our product, right? Our charger. We want to design our charger. What we are going to do is to, let me start it again. Under libraries, you type transformer, or you can actually go down. You can actually click on all libraries. You can go down. you see different components, audio devices. I want to go slow so I can see them. Connector, this space for connectors, CLD, crystal oscillators, Cypress connectors, another set of connectors. Then DC to DC converter, DC power jacks, diodes, display LED. So every component that you need, you want to create, you actually get to see them here, and you get to access them and see them after you must have turned on your library manager. You must have turned on the libraries in your library manager, which are these ones. So we want to design our product. So we'll be starting with the transformer, right? Because we want it to have oh sorry, I didn't type. So we'll click on this. Once you click on a component, you see it down here. So just at the lower left, that's where you see your details. If you click on attributes, you see the attributes, though it's not fully detailed, but some components, some models have theirs detailed as well. So as much. So you keep on going down to look for the type of transformer that you want to use. So, but we'll be using the most basic, transformer, the one that represents the ideal, the ideal transformer, the one that we all know. Also, okay, let's use this one. So you double click. Once you double click, this will show out. This will show. I said that this is a transformer, okay? This is a library. I've searched for transformer. You see many varieties. I want us to be on the same page. Are you following? These are different models. Out there in the market, you will see many transformers. There are different models. Just like you have a phone, but you have Redmi, Techno, Itel, iPhone. So it's just like when you have, okay, let's just say an Itel product, a phone. There are different versions, there are different models of Itel phones. And there is the first Itel, second Itel. So this is how it is here. All right. So we are using this very basic transformer now because we want to create this circuit. And once we are done, just click on it twice and then bring this will show. You see my cursor. This will show. You can actually rotate it either way that you want, but this will show, and they just how to rotate it depends on how you want it to be positioned. All right. If I click on this, you see another adjustment. Okay. So that's just it. So once you are done, you click on escape or done. So the next thing that we'll be looking for, are we there?
No, we are not.
Okay.
We are not. We are having difficulty using the transformer that we are using.
Okay. Let me start it again. Under libraries, you type transformer, or you can actually go down. You can actually click on all libraries. You can go down. You see different components, audio devices. I want to go slow so I can see them. Connector, this space for connectors, CLD, crystal oscillators, Cypress connectors, another set of connectors. Then DC to DC converter, DC power jacks, diodes, display LED. So every component that you need, you want to create, you actually get to see them here, and you get to access them and see them after you must have turned on your library manager. You must have turned on the libraries in your library manager, which are these ones. So we want to design our product. So we'll be starting with the transformer, right? Because we want it to have oh sorry, didn't type. So we'll click on this. Once you click on a component, you see it down here. So just at the lower left, that's where you see your details. If you click on attributes, you see the attributes, though it's not fully detailed, but some components, some models have theirs detailed as well. So as much. So you keep on going down to look for the type of transformer that you want to use. So, but we'll be using the most basic, transformer, the one that represents the ideal, the ideal transformer, the one that we all know. Also, okay, let's use this one. So you double click. Once you double click, this will show out. This will show. I said that this is a transformer, okay? This is a library. I've searched for transformer. You see many varieties. I want us to be on the same page. Are you following? These are different models. Out there in the market, you will see many transformers. There are different models. Just like you have a phone, but you have Redmi, Techno, Itel, iPhone. Hello? Are we there? Okay, so it's just like when you have, okay, let's just say an Itel product, a phone. There are different versions, there are different models of Itel phones. And there is the first Itel, second Itel. So this is how it is here. All right. So we are using this very basic transformer now because we want to create this circuit. And once we are done, just click on it twice and then bring this will show. You see my cursor. This will show. You can actually rotate it either way that you want, but this will show, and this is just how to rotate it. Depends on how you want it to be positioned. All right. If I click on this, you see another adjustment. Okay. So that's just it. So once you are done, you click on escape or done. So the next thing that we'll be looking for, are we there?
No, we are not.
Okay.
We are not. We are having difficulty using the transformer that we are using.
Okay. Like I said, just type in transformer.
Buji, can you drag that
Yes. Not
library?
that.
Just drag it a little bit to the right so that you will see the full name of the transformer.
Okay.
The
It's
name of the
not
library.
actually okay. No problem. I get what they mean. Okay, see what you're going to do. Type in this. Are you there? Type in this. Are you seeing my screen? What I highlighted, number I highlighted. Yeah. Just type it in here.
No components found. No components found.
It's showing on mine. That means that your library for it is not being turned on. You have to switch all your libraries on. Okay, search for any other transformer. I don't know. Can you see any other transformer? Can you see any other transformer?
Yes, sir.
Yeah, okay. Just use that transformer. Use the transformer, okay? We have a lot of things to cover today. So this transformer is for step down, okay? And let's get an input for our transformer, our device in general. So we'll be looking for connectors. Okay, definitely not this, not this, not this, and this. Okay, let's search for 2-pin. Okay, so more like on board. This more like single pins. Okay, let's use the onboard, all right? Because there's no time. We have a lot to cover today, so no time. So we can add in a fuse. Oh, okay, let's just move on. Then the next will be we are looking for a diode, right? For rectification. So we're looking for a diode that can actually get, let me use this one and okay. This is a 3 watt hour. This is a 3 amps diode. So we are going to construct a full rectifier circuit. All right. So it gets a capacitor. Type for a capacitor. Not typing. Okay. Capacitor. Okay, let's just be. Are we following? Are we following? Are we following? So this is basically our rectifying circuit. So in terms of connection, all right. So for each and every one of these components that you have gotten, now these are rectifying circuit, all right? So for each and every one of these components, if you want to drag it, you have to pick on it. There's always a space. If you look close to this, you will notice that there is this extension, this very thin line. It's actually a cross, but because of this red thick part of this component, it's kind of hidden. So if you hold on it, you can drag it to any place you want. And for this one, this is for this line, this label here. And this one, if you click on it, you can drag this anywhere. If you click on this, you can actually drag this anywhere. Sorry. What's happening? Okay. So like I said, you can just click on this, you can drag the components anywhere around. This way, this is to help you adjust your schematics when you are done bringing in the components and you want to start connecting. So if you want to make the connections, we have to go to this net, click on this, click on this. So this, connect this, connect this, connect this, connect this. All right, so this is going to, what's happening is actually now. You will see this. connect net segments N4 and N7. Now, if you move this apart, let me close this so that I can explain well. Let me close this so I can explain well. This is N1, N2, all right? Hello? They're not responsive. All right. So we have to move over to this one. Oh, let's make it a little bit beautiful. You click on escape to leave it. All right. And when you come here, so connect this to this, connect this to this. The next, we are now done with this part, okay? And what we will be getting out of this part is actually around here we'll be getting out 12 volts, and we will have to label this. Have to change user. Remember, I said that if you want to change the value of this, now that you have used this, is going to be important for the manufacturers. Okay, so we want to change this because we didn't use any particular transformer, all right, for the sake of this tutorial. So what we are going to do is to come here, click on this, come here, click on the components. We have to change because normally it's labeled T1. So the value for T1, we are going to change it from 18.36 volts input to 220 volts input. Okay. So okay, let me just see. Okay. So this is the main jack, and here we have our capacitor. So it's now time to label this to be this is going to be our positive terminal, and this is going to be our negative terminal. So if you want to shorten the length of this, you can, drag it. You want to shorten this, just to make it look neat. If you want to cancel anything, you can, click on this and then cancel. So moving over to the next section of the circuit, this is the power section now. If you want to, we can actually group this actually. Go to this point, click. So you can do that with any components. No, it mustn't be the transformer or anything. Just click on this, like here, you can see these 10 line here. So this one says here, new group, only the power circuit. All right. So you can see now that it's grouped. Are you with me? Hello? Sammy, I didn't have any issues there. All right, so moving over to the next section, which is the main charging section. So we'll be needing a voltage regulator to just keep a steady voltage. So we'll be using our linear regulator. Use this. Yep. Yeah. This is the 3D model, this is the 2D, and this is the schematic view. So if you click on any one of these, you get to see them, how they will appear, so that you will know which one to use. So I'm going to use this. If you also click under this, you will see varieties. So, and this one is the one available. These ones do not have 3D views, 3D models. The model is not complete, but this one has a complete model. That's how the libraries come sometimes. So we have this, and we are going to have another one here. So we are not going to do the calculations for this for the sake of time. But I can give you I'll reference you to online, to Google, to help you out. Google is always your best friend. So here, these are inputs, and for this place has to be connected to this, and we also be having a resistor here. So let's bring in a resistor. Let's bring in a resistor. How many ohms resistor should we bring? Okay, that should be 5, 4.7, and 517. So just get resistor, then give it a name. This file. Resistor. What is showing? Let's just go to the general. Okay. Go to R. R is way down. R is way down. You can hear me, right? Okay. So go down. R is way down. Resistors. Yep. So you click on this one. This one is most likely to have. Yeah. So which ones are we? Let's use this one. Yeah, this one. So we use this. Having one here and also one here. Here. And we press escape. We have to take this guy to this side and also take this guy to this side. You can click on the right button to change the positions of these labels, and so also is the components. If you click on your mouse right buttons, you can change the positions. So sorry, I forgot to mention that earlier. So we have to link this to this. I have to link this to this. I have to link this to this. Yep. So next is that we are going to need a capacitor. Click on the script and go to the capacitor section. Click all libraries. Go to the capacitor section and why is it loading? Loading, okay. Yep. So we go all over to C capacitor. So we can actually type capacitor to give us a list. Capacitor. Okay. So we choose this one. Well, I choose this one because these ones, they most of the times don't really have what you're looking for. because they are either incomplete or contains a lot of incomplete modules. So we just have to choose over, go over to the piece faster. Let's move over to this one. Yep, so we'll be choosing, okay, this one is good. This one is good. So we'll be choosing this. Like I said, right click to change positions, okay? So this plus, okay, I don't need to explain now. This means that it doesn't have any polarity and we're using this polarized capacitor. It's not polarized capacitor and we are connecting. So we have to remove this, please. So you see our design is actually setting just little by little. All right. So let's go over to this other side and make a good completion of it. So we have to come over to this place. This is where if you want to select, that's where I always click if I want to select something. If you click on this while here, if you click on any component while here and you want to drag it, will automatically switch to this place. But if you want to still be specific, no problem. But to save time, this interface already knows what you want to do. It doesn't work always in other specific conditions whereby, for example, this, if you click on anything, it's deleting. So for the sake of time, connect to this and we connect. We move up a little bit. Yep. And go over to this to drag. Let's drag this component, make it a little bit closer. And let's bring this down a little bit. Okay, so now we will be having this guy and this guy. So did you see what I did? I selected all and right clicked. Yeah, so that I can actually be easier for me. So I'll have to add a jack connector, or you can actually go to our other connector and pick on them, but I need an onboard because, okay, let's see what it is. And I want us to get to see something. I will be showing us something later when we enter the 2D view. All right. So when I reach there, this is going to be as a situation in a situation whereby you look for a very particular component and you didn't see it, just like the way we search for the transformer. What you have to do is to migrate to your to your 3D model part. Maybe you can go to the mechanical, just switching over to this place, go to manage. It's not yet installed on this account. So what you have to do is to download an extension called Snap EDA. Now with Snap EDA, it will enable you to actually bring in components and you'll be able to use them for your model, components that you do not have on your library. You know, after switching every library on, the component that you do not have, you can import them. These are components that other people and other manufacturers has made. So it doesn't take much time though, but it always works in a situation whereby this one keeps you hanging. So let's go for connectors. Sorry, we are still under capacity. Go on to all libraries. Go to okay, go to connectors. close connector. Click on this one. Let's check this one out. No, not this one. Yeah, this one, sorry. So check this one out. This one is 3. This one is 2. Okay. So we'll be using this one. For the sake of time, no time to check all these out. So we just have to use this one, okay? So we use this, and then because we called it a 3S, right? So what this will handle for voltage regulation, and this will handle for current regulation. If you go through the documentations online, you will see the calculations behind this. All right. So for the sake of time, I have a lot to cover today. I'll have to link this, and then link this to this. So we call it 3S. So we'll give this place a name. Call it positive. Now, yeah. So we are giving our line a name, right? So once you click, okay, let us say, for example, we have designed a section. This is the power section that contains the transformer, the input, the step down, the rectification, converting AC to DC, and all that stuff, right? So this is our negative, and this is our positive. So now we want this positive is supposed to be connected to this place. So what we are going to do is to give it the same name, give this line the same name as, give this line the same name as this. And the system will understand that, okay, we want to connect this line to this line, all right? So that's what we are going to do here now. I just want to explain it before doing it so that you don't miss out. Positive, typing it comes out, you click, say, oh yes, connect this N5, and positive, say yes. So it comes, you click on right button to with your desired listing. You also click on this, with negative, it shows, click, accept, yes, and voila, there we are. So now it's to actually organize the main thing, So for these circuits, they will be needing some components which are actually resistors, a BD140 for regulation, and also in conjunction with a TL431, which is a transistor. So we'll be connecting from here up. This is supposed to come close. I want this to be small. So, though, if you want increase your distance from here to Jerusalem, it doesn't still mean, you understand. But the main actual sizing of your PCB comes when you are talking about 2D. All right. If you like, let your distance just so any way that suits you for better arrangement and distance. This what suits me. This how I love getting mine done. So that just it. So I'm starting from here. I'm clicking here. I'm getting something here. Maybe I should just leave it here. And maybe if I should just move it, increase it a bit. Yeah. So increase the bit. Yeah. So I'll be introducing my resistors. I'll have to cover for the. I'll just have to click on this one. Copy. You see the resistor will just automatically follow my cursor anywhere it goes. So I'll just have to drop it here and also drop it here. I have to drop it here. Okay, so I think I'll be needing it one more time. You can see that it's giving label. If you click on it, it automatically knows, okay, it seems like you're not yet done. All right, and you still need more. So click on it here. So we'll be needing a variable so that we can actually be able to set our voltage limits for the cutoff. So the variable is resistor. You just have to go all libraries, resistor, and they are here. So we are looking for a variable. So you can see that this is just unlike the normal resistor that you know. Looking at this lower left part where you see your 2D model, this is just the low. This is a symbol. This is a symbol, the representation for your normal resistor that you know. The onboard, sorry, not the normal, the onboard resistor that you know. So you just have to keep on looking for, okay, let me just type variable resistor already. Variable resistor or potentiometer, anyone. So okay, we have this one here. So I'm going to use this one. I'm going to be using this one around here. And then okay, so right. Then it's time for us to get a TL431. So TL431. TL431 for those. Okay. Okay. Yeah. The symbol I'm looking for. So if you realize, you see that this component is kind of not complete. Wherever you see this, it means that the 3D model is not there. This is just a mere replacement, a default replacement for 3D models. If the 3D models are not there, then you will see this. All right. Remember when we clicked on this our LM. Let me just get this out first. Let me just get this out and place it here. To mirror it. Yep. I have to mirror it here. So remember when we clicked on this place, this our voltage regulator. Let me search for it again. We discovered that you see, just unlike this other one, it has this one. Yeah, you can see a 3D model, right? So this 3D model, this is to show you that it has, the library is complete. Some libraries are not complete. They just give you options, all right? And it's better that at least you found a library than to not find anyone at all, because that way means you going to create your own component, your own library, and that's another course out from this one. So we don't want to do that. It's stressful. So we just have to just, not really that stressful, but you have to be ready to model a 3D mechanical, give a mechanical model to just get this, all right, and then link it up to your schematic models of this. So that just it. So for here, you discover that this guy has no 3D model. So when we will be pushing our model, our PCB to the 3D, you are going to realize that you won't be seeing this. All right, so that's the reason why you have to just give the name, so that the manufacturer will also have to know what you need to be in that empty spot. The name is going to be shown there, so that when they will be fixing everything there, they will also get the required components and then fix it up. So that's just it. We'll be making our connections now. So for this one, let go back to our nets to make our connections. Oh, I forgot. We need a transistor BD140. BD140. It's lacking. So okay, this one is not complete. This one not complete. Okay. Okay, we'll be using this one. So this one is not complete. This is more like the real thing outside. Here, I think this is more like this is more like an onboard. So we'll be using this, which is a put-through hole. So as this is an onboard, this is a put-through hole. So we are going to be using this one. So going over, we are going to fix this here. And that's it. We are still going to do this for each and every one of these two guys, but this is just for one series. So one parallel, sorry. So we are going to pushing this guy, shifting it, then bringing this guy out, bringing this guy out, then connecting. Then bringing this guy, then bringing this guy. Then this guy will have to be connecting to this guy. You have to ensure that all your targets are closed. So okay, this guy connected to this place. So this is a voltage divider, all right, and is to enable our battery to actually charge, and it's more like a triggering system for ground. It just works the way MOSFET work, but this time around, since we are talking about DC, we are using this guy. So I have to move this guy, make a proper situation. Also make a proper situation here. So after I do this guy, then reconnect. Yep. So for here, we'll be coming this way. This guy. So the next thing that we'll be needing in our circuit is actually diode. Okay, where's that diode that we used before? Let's use it. Let's use it. So let's use an iron for, sorry, for 7. Let's use it. This is the other one. This is a 1 amp. So yeah. So you can see this is the 50 diode that we are using here. So it's labeled D5. All right. So 1, 2. The work of this diode is just to, get energy off. When the energy is being cut off, it's being used to nothing. So the work of the diode is to actually consume power. Wait, where is copy? We need another resistor so that once our store is full, it just triggers. So at this moment, we are looking for an LED. Which LED are we going to use? Okay, should we use this one? Or should we use this one? This one is more big. It depends on your choice of LED, all right, with respect to exposure. How do you want it? So this on board, this bigger size. Maybe we can let's use this one. Let's use this one. So coming here, we put this one, we mirror it so that the arrows will be on the other side. So we push this a little bit, push this a little bit. So pushing this a little bit, we come to this place, we connect, so that why this gets okay. So click on this. Any questions? Any questions so far?
Do we have any questions?
No questions, I can continue.
Right.
All right, so let's get this shifted. So I will be remember. So let's make it clean and smooth. So that's we're going to reduce this. We're going to actually elongate this. So elongate it so that we can have more space for this kind of stuff again. And elongate this also. So all right. So alright. Oh, so Simply copying this. I've explained that before. Okay. Hello, guys. Do you understand so far? Please. Sir, please say something, please. Okay. Okay. Yeah, I'm duplicating it exactly. Remember, I said this is for one para, right? So we are doing. We said that you understand what a 3-cell battery is. Okay, so let me get this done. I'm trying to be fast because we have to also cover and then give space to our man who didn't finish yesterday to finish up today. So any problem? So you will notice that I would like to also say something. During PCB, during product design, during the stages, you will also any problem during the stage of product design, you will be moving back and forth. All right, you will be moving back and forth, especially before your prototyping and during your prototyping, you'll be moving back and forth. So I will always tell you that I would like to tell you that it's always very, very important that you do everything on paper. You do everything on paper so that when you will be ready, before you can export anything, okay, when your schematic is ready, you are fully sure that, okay, this works. That's when you then have to model it. All right. And it's also professional that in whatever you are doing, so far you are modeling, no matter what project it is, always ensure that you keep documentaries. It's very, very important, especially in an official, sector. All right, in the official sections, it's very, very important. So that is the little tip I would love to give. Let me drag this up. Yeah, we have a negative. Yes. So we have this complete now. Okay. So with this being done, sorry, you can make this to be the second. It's always very important to actually group your schematics because it's always very important to actually group your schematics because it helps you to not get confused. You know, if someone else, if another engineer is actually going through your schematics, they will understand and say, okay, this is what he was trying to do. They'll be able to read it and not get confused. So now that we are done, the next thing to do is to push over to 2D. So we wait, and boom, here we are. So I would also love to say something here, okay? Before you actually start arranging these stuffs and every array, all right, you have to pick a board size. Okay, you have to pick a board size. Which board size do you want to give it any shape? All right, but we'll be doing that later on. Let's expand this, all right? Then select this whole thing and bring it in here, or we can still leave it outside. Oh, and I think we forgot something, so you can switch over. Now, this is the PCB that when we pushed, this file got created. You can see my cursor. This file got created automatically, so you can switch in between. All right. So we forgot to include a heatsink because there is no fan in this circuit, and these linear voltage regulators, this LM317 is going to, though this is not the precise voltage regulator to be used in the circuit, but for reference for this tutorial, we are going to be using this. So we'll be adding a heatsink. We are adding a heatsink. So what kind of heatsink? We have this big one. This is the only heatsink available in this library. Okay. And we'll be using it. You just have to bring it in, just drop it anywhere. Okay. Let's just fix it to this. And then fix it to this. Then it depends. Your transistor will also overheat, but you'll be needing a different kind of heatsink. You can actually discuss that with your manufacturer when it comes to this kind of challenge. So, hello, anyone saying anything? Any problem? Any problem? Tolu? Tolu, are you there? Wait a minute. Oh, I just discovered this. This line is actually supposed to not be here. So we have to change it and make it, add it to this place. We didn't complete it. Exactly. Yes. So we have to remove this. Yeah. So in the absence of any problem, we have to push again so that it can appear. Now you can see our heatsink has appeared here. And I would love to point out something. Remember, we searched for heatsink, right? So that this would be clear to you. Heatsink. Search for heatsink, and you can see this is the 2D representation. All right. This is the 2D. This is the one that you see here. When I click on this, this is the one. I can't reference this, like I can't mention this enough. This is the one that you see here, all right? So this one is the one that you see in your PCB 2D design, all right? This is 2D. Now the actual 3D is the one that we are going to after this one. This one is going to take us a little bit of time. So that's the reason why I'm trying to rush, so that the other engineer can enter and then finish up from where he started yesterday. So okay, which one, how are we going to start? Where's our transformer? This is our transformer. It's small here, so we're going to be using it in the basic. Well, where should we keep our inputs? Okay, just leave it here. Then look for the quite small though for this, so you won't be able to give us 3 amps. So okay, I think we'll have to rotate this. We'll have to rotate this. Just have to play around with it. Have to rotate this, keep this. Then for this one, just get it set, and over here, where's the other? They're in, pick them out from there, bring them here. So okay, so let's give it a proper arrangement. Just to give it a proper, arrangement. So keep it close. Okay, so we have our of this guy ready, and we'll be having these guys. Remember, like I said, these components, because of this class wasn't carefully selected, we just have to rush over. So do not think that this is a perfect design. If you want to do yours, you can actually do that on a personal level, make your research, follow the actual stages of product development, and then implement yours. So this is our big guy. How are we going to keep him? Guy is too big. Okay, so let's keep him. This transformer is not, it's not there, but just for the sake of this. So using this, we're going to take a little bit of time. This one too. To expand the board. Okay, so I'm in here. I'm bringing this one in. So I'm bringing this one here. We have to organize this. Then for this, anyone saying something? Anyone saying something? Tolu? Okay. So with respect to our first design, we have this guy. So making reference to our schematic drawing, we have, oh, I didn't even add for these guys. Okay, here's what's gonna happen. Okay, let's add for these guys because they are very, very important. So this here is going to be this here is going to be 4.7 4.7K. Give it a 4.7K. So everyone saying something. Okay, 517 ohms. Then for this guy, it's going to be 100 UF. This to be it's small attack. So for this one, it's going to be a 20 ohm, but they're about 20. Let's go 20 ohms. 20 ohms and this. There's supposed to be another capacitor here, so we're going to use let's just say just call it 100 ohms. So here, copy. Then push. So you can see that the update that we made here just appeared here, right? So this transformer, a transformer is funny. It's very small. All right. The LED 1, LED 2, LED 3. So this LED is connected to this one. So this is actually on. And then here we have R5, R4, R6, R7, R5, R4, R6, R7. So R4 to 7. We just have to carry them, bring them here. We didn't them for this, then for this one. GR2. PD140, yeah, so we still have to give this to TL43. TL43. So that's it. And so 8, 9, 10. 8, 9, 10, 11. So from 8, 9, 10, 11. It's 9, 10, 11. 8, 9, 10, 11. This is it. So we just have to take them to where it's coming in between. So this key to write. So this PD140. It is Q1. So one with also this Q2. So these guys. This is actually going to be with this guy. And LD1 is going to be with this guy. And these guys are going to be this guy. Going to be with this guy. LED3 is going to be with this guy. So we are looking at R12, 13, 14, and 15. R12, 13, 14, and 15. So R12, 13, 14, and 15. R12, 13, 14, and 15. So you can hold on to control to click. Depends on which one is preferable for you and which one you need at that very point in time. Any problem, please? So here to here 4 and here 6. Why do we here 2? Here 4. Here 6. Oh, actually carry the level, not actually the component. So I have to get this. Okay. Okay. So what I've been doing was just to arrange this in sectors. So these are yeah, okay. VR1. Which one? Oh, these are outputs. The input, sorry, to the transformer. I have to come over here. Then for this guy, I have to take it off. PD4. Five, 6, 7, 8. So for the first 5, 6, 7, 8. So let me go to this. 5, 6, 7, 8. 9, 10. So this is our port.
Excuse me, sir.
Yeah, I'm with you. Yeah. Come on.
Okay, so is there a reason why you're pulling things up and down? Is there a specific location they are meant to be? What's informing the arrangements that you're giving?
Okay. The reason why I am arranging them is because when it comes to routing, after the arrangement, we are supposed to enter into routing. All right. Now, if we are to go into routing, we are going to have a disorganized board, and these things are these components are going to be hard for routing. And if we say, okay, let's do it, let's just put everything together, bring everything together and do auto routing, because that's another type of routing, which I'll be taking us through. It's still it's going to mess everything up. All right. So this part takes time. That's the reason why I've been rushing, so that we can be able to get out more time from here. Get out more time to be used here, sorry. So that is it.
So if we are doing it by ourselves, how are we supposed to know the exact position to put certain components on
Okay,
the
you
board?
don't actually, yeah, you don't actually need a position. You just have to follow your sketch. Like what I'm doing here is that I am following my sketch so that I can arrange everything. You notice that here in this sketch, everything here is just together, you get. So if you want to do it, randomly, just the way it is, the routing is going to be bad, and you are going to have multiple errors. At that point, you'll be seeing a lot of, error marks popping up here around this region, and that's more time for you. So this part is the part where you have to carefully, put them in clusters. That's what I'm trying to do. All right, are you understood? Am I understood? Sorry.
And it's
Okay, let me throw more point. Okay. The thing there is that this place, this stage where we are at now, it requires is the stage where we have to do some arrangement of the components on the board. All right. This is a very big surface. This is a very big surface, and we are trying to make this thing to match, to be within a small dimension. We do not have any dimension in mind. Are you with me? Yeah, we do not have any dimension in mind. So what we are going to do is to just reduce this and make it. If I want to push this thing now to PCB to 3D, we haven't routed. And for routing, this is where we do our routing. Okay. If you want, this place is just for polygon. If you want to create another shape, this where you do it. But that's not what we are in for now. Okay, so let me just click escape and then go back to this so that we can be able to do this. But I'm almost done though. So I know that this is taking a bit time, but so I'm done with this area now. Let me just get this done. Then we have to reduce our